Hi students, today we are going to start a new chapter, fluids. Now when we use the word fluid, the first thing which comes into our mind is water or any kind of liquid. But not only liquid, gases also come under the category of fluid. Why? Because fluid is defined as any substance which can flow. Any substance that can flow comes under the category of fluid, which means gases and liquids comes under this category. Now let us see what are the important characteristics of a fluid. You have studied some of it in your lower class. The first one is the atoms or molecules are randomly arranged in the case of a fluid. Second one, a fluid cannot withstand shearing stress and flows when shearing stress is applied to it. You know what is stress? Stress means force by area, and shearing stress is also known by the name tangential stress. So whenever you are applying tangential force to a liquid, definitely it will start to flow. Next one, a fluid does not have any shape of its own. It occupies, or it takes the shape of the container or the vessel in which it is kept. And the next point is, a fluid can exert or it can withstand force in a direction perpendicular to its surface. A fluid can exert force in all the directions in a perpendicular direction. It cannot be at an arbitrary angle, it cannot apply a force at a particular angle, but it can always apply force, or it can always withstand the external force in a direction perpendicular to it. These are the important features or characteristics of a fluid. Now, even though both the liquids and gases come under the category of fluid, let us see what is the difference between a gas and a liquid. We'll take the example of perfume. Okay, you know, if you take a perfume bottle and if you shake it, you feel like it is a liquid, but actually it is what? It is gas. What is that? It is because in the case of perfume, the gas molecules are brought together by applying a very high pressure externally. We call it as compressible. Gases are compressible. We can compress the gas molecules and bring the molecules very close to each other. If you take the cooking gas, we will call it as LPG, liquefied petroleum gas. Gas is being liquefied. How? By applying external pressure. We compress the gas molecules, we try to bring it close to each other by applying a very huge amount of external force, and hence we are compressing it. So gases are compressible and it is free to occupy the shape anywhere in the container. But in the case of liquids, it is not compressible, it is incompressible. We cannot compress a liquid and make it into a solid. Clear? Gases can be compressed, whereas liquids cannot be compressed. And definitely the liquids have a definite volume and shape. So the main difference between, one of the difference between liquid and gases, liquid is incompressible and has a definite shape. It has a shape of the volume of the container in which it is kept, whereas gas, it is compressible and is free to occupy, gas molecules are free to occupy the container or the vessel in which they are kept. Now, in physics, the study of fluids is categorized into two. There are two main categories for fluids in physics, which are fluid statics and fluid dynamics. Static means stationary. So fluid statics is a branch of physics which deals with fluid at rest, whereas fluid dynamics is a branch of physics which deals with fluid in motion, the one which is flowing. And there are certain laws in this chapter. You will be studying certain laws and certain factors regarding the fluids which are in statics, which are at rest. Similarly, you will be studying about certain laws of fluid dynamics, which means the fluids which are in motion. And the main term which we use in the case of fluid is thrust. We have studied about thrust. We are just revising the terms which we have studied in lower class. And thrust is the total force exerted by a fluid to the surface in contact, and it is always, its direction is always normal to the point of observation. Okay, and the unit of thrust is Newton. So total force, so unit is Newton. And the next term which we mainly use in the case of fluid is pressure. The pressure is what? Pressure is the thrust acting per unit area. It is the thrust per unit area acting normally to the surface. Not only surface, to all the directions. Now, if we take a beaker which is filled with a fluid, and if you take a particular depth level, then it is found that pressure at this level will be same in all the directions, which means magnitude of pressure at this particular depth or at this particular level will be same throughout the fluid, which means even though the equation to find pressure is force by area, and we know force is definitely a vector quantity and area is a scalar quantity, so definitely pressure should be, according to this equation, a vector quantity. But because of this speciality that at a particular level or at a particular depth, fluid exerts pressure in the same magnitude throughout or in all directions, we can say pressure is a scalar quantity. It is a scalar quantity. Now, why is it a scalar quantity? Why is it not a vector? Because the magnitude of pressure at the same level, at a level, is same in all directions. So these are the two terms which we mainly use in the case of fluid, that is thrust and pressure.